Hello and welcome to Season 2, Episode 2 of LogiCast, the weekly AWS news podcast. I'm Karl Robinson, CEO and co-founder of Logicata, and I'm joined today by my colleague, John. How are you doing today, John?
I'm okay. I don't think we've ever actually said what my job is at Logicata, have we?
I think we may have done in the in Episode 1 of Season 1, but, for any new listeners, feel free to elaborate.
Hi, I'm John. I am lead cloud engineer at Logicata.
Thanks for clarifying, John. So we have both just celebrated our birthdays this weekend, and I don't think either of us have achieved any particular milestone other than achieving another lap of the sun, as you put it. But did you enjoy your birthday weekend this weekend?
Yeah, it was all right. Can't complain. But now the proud
Yeah.
owner of a rice cooker, so all the curry I eat
Ooh.
will actually taste all right now.
Have you tried it yet?
No, not yet.
I can give you some tips on the rice cooker because we have a rice cooker, and it does tend to make rice a bit clumpy unless you do certain things. But that's a different podcast. So moving on from rice cooker tips back to the subject matter of AWS news. If you're new to the podcast, every week I curate a list of AWS news articles, which I distribute via my weekly AWS News Roundup newsletter. Then John and I pick a number of those articles that we'd like to just talk about in a little more detail. So we've got 5 such articles this week for you. The first of which is about Zero Trust and a new service that AWS launched at reInvent called AWS Verified Access, which helps you to give zero trust access to enterprise web applications. So, John, do you care to elaborate on zero trust access to enterprise web applications?
I mean, I would, but I'm not sure I can trust you.
Well, that is a great example there of zero trust. But but
Yeah, that was terrible. That was a dad
it was
joke, a
pretty
peak dad
bad.
joke.
We don't rehearse these things, so I cringed as much as I'm sure you listeners cringed at that one.
Oh dear. Okay, so zero trust. Let's start with that because it's probably something that people have heard, maybe, but not really gone into it in great detail. So let's start with what that is. In a traditional environment, i.e., in your data center, you do what's called castle and moat. Great term that. Everything outside of your moat, your firewall, your enterprise restrictions, your whatever, is not trusted, right? It's the enemy. You don't know what's there. No one's allowed in apart from over your drawbridge and through your portcullis. And then you're in the castle and you have access to everything. That kind of works because you're kind of filtering and restricting where people can come in through. In AWS VPC land, again, that's kind of what you're doing, right? In the oldie worldy, newy worldy kind of hybrid, you've got your VPC and you've got your security groups, and you're trusting things coming from one place to another place that, the web servers can access the database, but nothing else can access the database because you're coming from kind of the right place. Yeah, that's kind of a halfway house, if you like. But to get in, you kind of still need a VPN or a secure route or a static IP or whatever. Zero trust is you trust nothing ever, all of the time. Every single access request to any resource in your environment must be authenticated every single time. There isn't a wall. You're not worried about that because you just don't trust anybody. Wonderful. That's kind of a new way of thinking, newish. And it's quite an interesting one. It does add some latencies and things because you're constantly reauthing traffic and it's a little bit annoying, but that's kind of what that is. AWS's new service, what have they called it? It's called
Verified
Verified Access.
access. Yeah.
Lovely and on the nose that. It's not got some Greek name, which makes a change. Is kind of providing that for you, right? You integrate it with a trust provider and there's an access group. You need to get into the resources that are controlled by this access group. You get authenticated. Great, lovely. Rinse, repeat, rinse, repeat, rinse, repeat, and then you just attach it to kind of every resource that you care about. And it's not necessarily the same access group. You could have your web server access group or your database access group or your AWS Workspaces access group or whatever. And each of those just get auth for every request. It's something that's kind of been around by proxy, and there's a tweet from someone at Scale Factory, which is one of they're not really a competitor, they're kind of colleagues in the space because they sit in a slightly different area to us, have said that they've been doing it sort of through proxy features by lambdas and hooking those into CloudFront and VPNs and doing custom auth on every request. And again, you could do it with API gateway. Sorry, I was thinking of the wrong thing there. But by again having custom auths or JSON auths or whatever, JWT auths. Sorry, and you can kind of do it, but not on everything. And then this is just a proper solution from the vendor. It's in preview at the minute, so expect it to change a little bit, but in my experience and in your experience, no doubt, once things have gone into preview, they don't really change a huge amount. They might fiddle with the pricing a bit, they might fiddle with the logging a bit, but the core of what it's being offered is kind of there. And in that vein, the pricing is very not cheap. Would you like to know how not cheap it is? It's very not cheap.
Go on then. Tell me how very not cheap it is.
Per application and per hour of 27 cents an hour.
Ooh.
Yeah.
Yeah, that could mount up quite quickly.
Yeah. I mean, there's, again, someone at Appgate, the product officer at Appgate, has kind of said this as well, right? It's if you've got 100 or 1,000 applications that you need to be, it starts getting real expensive really quick. If an estate with 20 corporate applications could cost $48,000 just for your auth.
Wow.
Yeah.
So why would you use it then? Why? I mean, the article describes it as an alternative to VPN. VPN's obviously not going to cost anywhere near that amount. So why would you choose this over a traditional VPN?
Because VPN is still the old castle and moat strategy. Right? The VPN is your drawbridge. It's you're going through a trusted route and you're allowed in.
Yeah.
This is not that.
Yeah. Yeah.
But obviously they're going to draw parallels to that because that's kind of how everyone kind of still thinks about things.
So who's it for then? Who's going to be spending that amount of money on authentication?
People that have enormous bills anyway, and another 50 grand on the bill of $1 million a month isn't going to make a difference to them. It's big corporates, and one suggests this is less management of a VPN, right? Because if you have a VPN, you have to manage it. You have to make sure users have got tokens and users and passwords and all that kind of thing. With this, I think there's probably a bit less management involved.
So it's back to the traditional total cost of ownership argument that yes, it looks expensive on the face of it, but you're not paying humans to manage the VPN.
Because at the end of the day, in most organisations, the biggest expense is engineers rather than stuff.
Yeah. Cool. Okay. Well, I don't think we're going to be rolling that out, but potentially some of our customers may wish to. So that's useful to know. Moving on to the next article this week. It's about Amazon ECS adding automated rollbacks. So ECS, of course, being at the Elastic Container Service. And there's a new feature for automated roll. Yeah, it's my TLAs again, John. I'm on it again. A new feature for automated rollbacks during application deployments has been added. So tell us a bit more about this one.
This is cool. I like this. I suggested something like this to one of our clients. They didn't end up going for it for one reason or another. I think they're going to build it internally rather than getting us to do it. But I suggested this. But it's nice that what they've come up with is a way of just kind of doing it for you rather than you having to kind of kludge it together, which is what we'd have ended up doing. And then this had come out and then we'd have gone, oh, God damn it. Amazon does that a lot to me, I find. There's a problem, I work around it, and then they automate my solution. Great. I will probably tell them about this and say, by the way, that thing we suggested, it's kind of a thing you just got to turn on now. Go do that.
Yeah.
So this is a thing that Lambda has been able to do for a little while now, and they just kind of brought it out to ECS as well. What you do is in your deployment configuration, you also specify CloudWatch alarms based on the thing that you're deploying. Is it erroring? Is it throwing 500s or 400s or whatever? And an evaluation period, 5 minutes, 10 minutes, 30 minutes, and how much traffic you're going to send to the new version. So it's doing a blue-green deployment, and I'm not going to define a blue-green deployment right now because I've done that extensively on this podcast. But the short version is you stand up a new version of your infrastructure, deploy the new stuff on there, move traffic, and evaluate it. And that's what's happening here. And what it's therefore doing is if it sees errors above a threshold in your new infrastructure, It kills it off, moves all the traffic back to the old infrastructure, says, "Soz, it failed." What that means is this is not new. This is not a new thing. This is just they've done the undifferentiated heavy lifting for you, which we like because it means that you don't have to build it yourself. Like I say, Lambda's been doing this for a while through code deploy, and I think you could previously do this through code deploy for ECS as well, but it was a little bit kludgy, and it's just done it in ECS itself directly now, which is nice. It's just a lot less work, a lot fewer services, easy to do, that kind of thing.
So I take it you still have to define the CloudWatch alarms. You need to tell it what to look for?
Yes.
Or is it cleverer than that?
No, you have to tell it what to look for. On the Lambda side of things, which is obviously not this article, but it would just be if the Lambda failed, it would roll it back. For this, they've got, but you just had to specify the alarms, if that makes sense. So if the alarm, you'd set an alarm for the Lambda failing. Same kind of thing for this. It would be, if your alarm is going off, then it will roll it back for you. They've got suggested metrics in there, things like, HTTP 500s and 400s going above a level, CPU and memory spiking, that kind of thing. But yes, you have to specify your own metrics because what might be okay for you might not be okay for somebody else.
Yeah. Cool. So we've got a use case within our customer base already, which is great. So I'm not going to ask you whether or not you're going to use it, as I often do, because we've already identified that. So let's skip on to the next article, which is another one, still staying in the world of serverless, which of course is the world. It's no surprise that John actually chooses these articles, which is why we always end up talking about stuff that John likes talking about. Occasionally, I put my foot down if there's something that I particularly want to talk about, and we pick an article for me as well. But I'm quite happy for John to do most of the talking. So sticking with the world of serverless, this article is about the introduction of step functions distributed map for large-scale parallel data processing. No acronyms in there for me to define. So, John, tell us all about step functions distributed map.
So this isn't actually as new as most of our articles tend to be. The article that you found is new, but they released this at the start of December last year. So it's been around for a couple of months now, but InfoQ have only just picked it up, hence we've then picked it up. So I remember reading the announcement about this a little while ago going, oh, that's really cool. So, again, some definitions. Step functions, it's a way of orchestrating serverless workflows, yeah? So it can talk to Lambdas, SQS queues, it can talk to other step functions, things can talk to it. Excuse me, it takes inputs from SQS and API Gateway and a few other bits and pieces in there as well. It can talk to Dynamo directly and all sorts of cool things like that. It's not just a start to finish run jobs, it is a full-featured orchestration service like a proper task scheduler, like your Jams, Control M, others are available. Can do, you can, if this then that, and it can do map states and it can do parallel processing and it can do iteration and so on and so on. Excuse me. What this is doing is this is adding a new version of the map state. So the map state is, I have this input, I want to split this input and run through this chunk of 10 things at the same time to make things run faster, because I don't have to worry about throttling, for argument's sake. I've used this a bit. I've used this as one of our reporting tools, actually, because that reporting tool goes off and connects to disparate accounts, so we don't have to worry about being rate limited because we're talking to lots of different things. It's kind of useful for that. It makes things go a lot faster. Distributed map, what this is doing is this is basically uprating the concurrency from 40 parallel iterations to 10,000.
Ooh.
Big jump. Big
upgrade.
jump.
Big upgrade.
Yeah. And yeah, AWS recommend it, if you're orchestrating large scale parallel workloads with data sets bigger than 256K. And that's an important number because that's the biggest input that you can normally have in your step functions payload is 256K. So that's kind of one limit, or, and events greater than 25,000, or you need to have more than 40 executions going on at the same time because it'll sit there and it'll run out of time, or you need it to finish within X period of time or whatever. So that's kind of what it's for, basically. It's just spreading out your map state and making your map state a bit more powerful. There is
And
one little,
just
go
going to
on.
ask you what might be a real world use case for this. I think you mentioned one that we have internally. Perhaps you can describe that, or another real world use case for this, just to kind of bring it to life a bit more.
Yeah, so say you've got large amounts of input files that you need to crawl the files, get some interesting data out of them, slam that over into Redshift or something like that, and you've got 10,000 files, 100,000 files that you need to process, and you've got to do it within the space of an hour, so you can't just sit there churning. It's good for that kind of thing because Lambda will scale up and scale out to handle that for you. It will just run up to, I think, 10,000 Lambda functions concurrently. So long as you don't have downstream run constraints, like API throttling or whatever, then you can just scale out massively with this, run over an enormous data set, great for data warehouse ingest and that kind of thing, where you can't stream the data in if it's like static files and stuff, and crawl over these enormous collections of objects and just put them in very quickly. So that's one option. Option two, like for our scenario, is if you've got more than 40 customers that you need to report on, like the number of backups and whatever they've got in their account automatically, then again, you scale out so that you can do lots of them at the same time rather than sitting there churning them. That's that kind of thing. Realistically, I see this being very useful in the data space, data scientists, data engineers, data analysts, that kind of thing, using this because it's them that's using these massive, massive scale size data sets. So it's big data, if you like.
Cool. And I'm conscious I interrupted you. So have you made the point that you were going to make when I did?
Oh, I forget what it was.
Fine. Let's move on to the next article then. So sticking in the world of serverless, our next article this week is on the AWS Compute blog, and it's about Lambda. So the article is entitled Introducing Maximum Concurrency of AWS Lambda Functions when using an Amazon SQS as an event source. So what can you tell us
Sorry,
about
I've
this?
just had a complete tangent. I've come up with the title for today's episode.
Serverless,
serverless.
Well, I thought we might get the rice cooker in there, perhaps. But,
serverless rice cooking. Oh dear. Okay, so right, maximum concurrency of Lambda functions when using SQS as event source. Again, nothing for your pop filter. I'm disappointed.
No, nothing this week. No, we haven't got enough of that sort of alliteration in the articles this week. But maybe we can choose something next week.
Okay. Again, let's do some definitions. Let's do some background on this, and then we'll talk about this one. So, Lambda has a maximum concurrency by default, but it's something like 1,000 concurrent functions, which is, it's a big number. And it will add, 60 functions a minute up to 1,000 functions. So it has a concurrency anyway. Lambda can be triggered by SQS just as an event source, right? Message goes on queue. The Lambda service is doing the long polling so that it's just sort of sitting there listening to it. And then it triggers off your Lambda function. So you don't have to worry about all of that crufty, heavy lifting. Lovely. However, counterpoint to the previous one where you're talking about, you can scale out and do massive workloads provided that you don't have downstream run rate constraints. This is covering the other end of that, where previous thing that I've worked on before, fully serverless, lovely and distributed and event driven and all the rest of it, but we had constraints on the number of API calls we could make. We were talking to a non-serverless database that couldn't just go to hyperscale when we needed it to. And we were triggering these Lambdas off of SQS, and we had real issues when you got a lot of users in the system with SQS flooding the Lambdas and the Lambdas flooding out the downstream services, and everything just broke. At the time, we handled that by limiting the concurrency of Lambda. So you can do that. You can say, this Lambda may not run more than 2 or 5 times at the same time, and that's okay. But what that causes, as this article says, is if there's no concurrency available for Lambda to process, the Lambda service, not the function, the service, is actually still polling and going, I've got stuff to run, I need to run. And then it can't put it anywhere, so it sends it back to the queue again. And then depending on your retry settings, you can end up with things going into your dead letter queue or being completely dropped because you don't have the concurrency available to process the flood of messages that you've had, which kind of defeats the point of queuing, because the whole point of queuing is it will sit there until it has been processed. But it was this kind of really nasty halfway house where you were controlling how much your function could run, but the Lambda service was still trying to run things and it just couldn't. So you're in this really ugly halfway house where you ended up having, DLQs and then DLQs of DLQs and so on and so on and so on, that all eventually just filled up. And then when your flood had finished, you had to manually go in and point your Lambda at the DLQs in order so it could process them, which is just horrible. It was horrible. What this is doing is this is saying you can set a limit at the Lambda service level, so that you can say that this particular invocation may not run more than 5, 10 Lambdas at the same time. I think the minimum is 2, which is great, because what that means is it's not spinning around, kicking its heels in the Lambda service, and it's just kind of going, oh, no, we've run out. We're going to sit here and we're going to wait in the queue like you're meant to. You do still have to worry about things like visibility timeout and the max TTL on your queues, but set them really long and you kind of don't have to think about it, because I think the max TTL is like a week. So just set it really long and forget about it. So this is brilliant. This is wonderful. We really like this because, like I say, that way you can say maximum concurrency and we can have a nice controlled throughput, and we're not going to start overloading our downstream databases. We're not going to start overrunning our API limits. We're not going to get this enormous bill from a downstream API provider that we've had to run on.
Cool. So is it something you think you're going to be using?
Maybe. It's very much one of those, if there's a use case for it, oh, hell yeah, I'll be using it. I did send it to the team I used to work for saying, by the way, you know that massive problem that we had? Amazon have fixed it. So I did send it to them.
They're very good at that. Back to your previous point about them kind of automating things that you've been building yourself. They're very good at listening to customer feedback and taking away what they like to call the undifferentiated heavy lifting from these things. So, spot a problem and fix it. That's what I've always liked about AWS. So,
yeah, no, I've got no complaints about this at all. This is absolutely what we like to see. This is excellent. In this serverless project that we're starting work on now, I don't know whether we'll need this or not. I think there's a couple of event-driven things that will connect together, so we might end up needing this.
Nice. Okay, let's move on to our final article this week, and kind of sort of loosely around the edges of the world of serverless, but moving more into the ops space. We're back onto observability. So we spoke quite a bit about observability last week because we're seeing it as a fairly big trend, at least in the press, that is, for 2023. This particular article is entitled Why Cloud Observability Will Be Critical in 2023. Arguably, it's always been critical, but people perhaps have not been very good at it. The tools have not been very good at it. The tools have perhaps been a little bit expensive, particularly when looking at things like serverless availability. I think we've identified that on previous episodes, that monitoring things like Lambda functions can get very expensive very quickly. But as the article says, observability is critical and is going to become more critical in 2023. So why is observability so critical, John? Why is this coming to a head now? Is it just because people like writing New Year articles at the start of the year talking about what's going to be great in 2023? Or is there something actually happening in the space that is making it, pushing it up people's agendas, I guess?
Some and some, I would say. Some and some. We talk about observability quite a lot, or OLLI as it's shortened to, which is O11Y. I know we didn't explain that last week, so I will do there. In the same way that K8 is Kubernetes, because you take the eight characters, make it an 8. Take the 11 characters and make it an 11. So it's OLLI. Do the same with accessibility as well, and that becomes ALI, which is cool.
Ah.
Yeah,
that's a new one on me. Then
got some FLAs for you now.
Yeah.
Hang on, does TLA work if some of the characters are numbers? Because it's not a letter acronym; it's a character acronym.
Well, I'm not sure whether TLA is multi-purpose and can apply to 3-letter acronyms and 3-letter abbreviations, because acronyms and abbreviations are really two different
That's a
things,
good
I
point.
guess. So
You
yeah,
can't really go ahead and call it an FCA because that's the Financial Conduct Authority.
yeah, exactly. I might need to Google that one after the episode, after we finish recording the episode, and see if those, the definition of TLA is interchangeable.
Oh, it probably is. Right, so on point. It's some and some. There is definitely a lot of this. It's going to be popular for 2023 because we just come into 2023 and people like to write those sorts of things because it's. I mean, you write things, I write things. It's hard to sometimes come up with a tag to talk about what you're talking about for why. So it's you do at this time of year and towards the December end of the year as well. You say trends we saw this year, trends we think we're going to see next year. You get a lot of that just as like a hook. So there's certainly some of that going on. But observability is getting bigger. There's kind of no denying it. It is getting bigger. Why it's getting bigger, I probably couldn't comment, but from my perspective, it's because people have worked out that they haven't been doing this very well for a long time. In excuse me, in data center land, like I said last week, you used proxy metrics quite a lot for observing how your applications were performing. You use CPU utilization, you use RAM utilization, you use disk space and all that kind of thing, and a little bit of performance metrics, things like response times, AppDex metrics, those kinds of things, but not really. It was a lot of proxy metrics, and it was just a lot of noise in your monitoring, and people sort of stopped caring. Observability, I think, is trying to reframe this in the same way that DevOps has sort of reframed the ops space. Because again, it used to be developers existed, wrote code, threw it at ops. Ops tried to run it, it broke. They called developers, but developers were like, "Oh, it's the weekend. Go away. It's not my problem." DevOps came along and went, "Ha, no, it is your problem." So everyone kind of worked together a bit better and moved things along, and now we're in a better place than we were 5, 10 years ago. I think the trend towards observability is kind of doing the same thing. It was, the proxy metrics will be all right. It's up. We don't care. The AppDex scores are all right. It's fine. But you didn't really have any detail on why it was fine or why it wasn't fine. And the trend towards observability is giving you much more insights into how your applications are performing, where bottlenecks are, where you need to optimize your code versus just give it some more resource, that kind of thing. And then on top of that, all of this is great because it makes the UX of your end user better without relying on these proxy metrics.
Cool. So, obviously, observability is a huge part of what we do at Logicata for our customers. What are we going to do differently, do you think, in 2023?
I'm going to bang on about it on this podcast again and again and again.
Well, I think it's going to keep coming up. It's 2 weeks in a row now we've talked about
know.
observability. So, yeah.
I know. What are we doing differently? I don't know that we're doing much differently. Certainly with the trend towards serverless and with the serverless projects that we've got going on, this will be more important than just, again, looking at the proxy metrics, right? Because with Datadog, New Relic, whatever you might use, other tools are available. You just kind of install an agent, let it run, write some monitors, and you're away. Happy days. You just make sure it's up. Cool. With serverless and kind of that middle ground of like ECS, which is there are servers but the app isn't on the server, that kind of hybrid middle ground. It's a lot less easy to do because you can't rely on things like those proxy metrics. You need to make sure that it's got enough memory and disk and so on, but that's not telling you very much about the application. And certainly with things that we build for our customers rather than things that we just run for our customers, where we have more insight into the application, or where where the customers are paying us to look after the application as well as the infrastructure, then we need to care about what's going on under the covers. So I think we're probably going to have a number of internal discussions about the tooling that we want to use, because we like to have those conversations. And then we're going to end up going with CloudWatch anyway, because it's the free one.
Yeah. Well, AWS is also doing a lot more in the observability space now,
yes,
with some of the sort of managed open source tools that they have launched in recent years. I'm trying to think of them off the top of my head. Grafana, Prometheus and Grafana, managed Prometheus, Grafana, that kind of thing.
Yeah, no, they are getting a lot better. And I mock CloudWatch a little bit because it's always fun to just, no one at AWS is going to get annoyed at me for beating CloudWatch with a stick, but it has gotten a lot more mature and a lot better in recent years. It used to be really bad, and now it's actually viable that you can use it combined with X-Ray to get these insights.
Yeah, so I guess whereas in the past you would always have been pushed towards third-party tools to get the level of insight you wanted out of AWS, particularly at the application level. Now AWS is offering more tools or better tools in better feature functionality of the tools such as CloudWatch to help you get that data out.
It does also make for an easier sell to a customer environment because you don't have to say, oh, we've got this other tool that we want to integrate as well. It's going to cost you another $150 a month. It's, okay, so you're probably going to pay a similar number, but it's on your AWS bill anyway.
Yeah. Certainly makes the procurement easier, makes the back office management easier. So a lot to be said for that. Although on the flip side, I've often thought that monitoring AWS with AWS perhaps doesn't sit right with some people.
Who watches the watchers?
Exactly. So I guess that's going to come down to personal preference.
Yeah, but the grand irony being that a lot of these external tools are hosted on AWS anyway.
Exactly.
So unless you're making,
we were having this week.
Yes, unless you're making damn sure that your tooling is hosted on GCP, for instance, then it kind of doesn't matter. Especially given that things like CloudWatch is a global service, I think. So it kind of it's in all the regions, it's in all the data centers. If you lose an AZ, it shouldn't really break it, so it should be okay. But there is certainly an element of trust going on there. Yeah, absolutely.
Fingers crossed for those listening and not watching the video. So anyway, that brings us neatly to the end of our time for this week. So that was season 2, episode 2 of LogiCast. Thanks for listening all the way to the end. We'll be back next week with another episode talking in depth about some more of the AWS news that we find in the coming week. So thanks, John. Thanks for listening. We'll see you again next week.